From the vast expanse of space, Earth appears as a tiny, fragile sphere, a pale blue dot suspended in a sunbeam. Yet, this seemingly insignificant world is teeming with life, an oasis of diversity in the cold, dark void. How did this remarkable phenomenon occur? How did life emerge from the chaos of the early universe? The story of life on Earth is a tale of cosmic proportions. It's a story of chance encounters, extreme conditions, and the enduring power of life itself. Our planet's journey began billions of years ago, amidst the swirling dust and gas of a nascent solar system. From these humble beginnings, Earth would evolve into the vibrant, life-sustaining world we know today. The emergence of life on Earth is a testament to the intricate interplay of cosmic forces. The precise conditions required for life are rare and precious. Our planet's unique history and position in the solar system have allowed life to flourish. But the question remains, are we alone? Or are there other life forms out there, hidden among the stars? The formation of our solar system was a chaotic ballet of gravity and matter. A vast cloud of gas and dust, remnants of long-dead stars, began to collapse under its own weight. At the center of this maelstrom, our sun ignited, its fiery birth sending shockwaves through the surrounding nebula. From the swirling disk of debris, planets began to coalesce. Tiny grains of dust, drawn together by electrostatic forces, formed larger and larger clumps. These clumps, in turn, attracted more material, eventually growing into planetesimals. Over millions of years, these planetesimals collided and merged, forming the planets we know today. Earth's position in the solar system proved crucial for its future habitability. Our planet formed in what we call the Goldilocks zone, a region around a star where temperatures are just right for liquid water to exist on a planet's surface. This liquid water, as we know it, is essential for life as we understand it. While Earth's location in the habitable zone is essential, it doesn't tell the whole story. Two intriguing mysteries, known as the Thar Paradox and the Water Paradox, complicate our understanding of life's origins. These paradoxes highlight the delicate balance of factors needed for life to arise. The Thar Paradox, also known as the faint young sun paradox, points out a discrepancy in the early solar system. The young sun was much fainter than it is today. So faint, in fact, that early Earth should have been a frozen wasteland. Yet geological evidence suggests that liquid water existed on Earth's surface billions of years ago. The Water Paradox adds another layer of complexity. It questions the origin of Earth's water. The early inner solar system was a hot, dry place. Where did all the water needed to form our oceans come from? These paradoxes remind us that the emergence of life on Earth was not a foregone conclusion. The early Earth, during a period known as the Hadean Eon, was a far cry from the hospitable planet we know today. Imagine a scene of unimaginable violence and chaos. Volcanoes erupted with ferocious intensity, spewing molten rock and noxious gases into the atmosphere. The surface of the planet was a cauldron of molten rock, constantly bombarded by asteroids and comets left over from the solar system's formation. These impacts delivered immense amounts of energy, vaporizing any water that dared to condense. The atmosphere was a toxic soup of carbon dioxide, methane, and ammonia, devoid of the oxygen we breathe today. It's hard to imagine life arising in such a hellish environment. And yet, somewhere in this primordial soup, the seeds of life were sown. The ingredients for life, simple organic molecules, somehow managed to form and persist amidst the chaos. Section 5. From Mars to Earth, a cosmic exchange. While Earth was enduring its fiery youth, our planetary neighbor, Mars, may have been a very different place. Evidence suggests that early Mars was warmer and wetter than it is today, with a thicker atmosphere and possibly even oceans of liquid water. Could life have arisen on Mars before it did on Earth? And if so, could Martian life have been transported to our planet? The idea might sound like science fiction, but it's a possibility that scientists are taking seriously. Meteorites from Mars have been found on Earth, blasted off the red planet by powerful impacts. These meteorites contain organic molecules, the building blocks of life. It's conceivable that Martian microbes, hitchhiking on these cosmic travelers, could have survived the journey to Earth and seeded our planet with life. The intriguing possibility. The idea that life on Earth might have extraterrestrial origins is a profound one. If true, it would mean that we are all descendants of Martian microbes, carrying within us a legacy of a lost world. The possibility is both humbling and exhilarating. The search for evidence of past life on Mars is one of the most compelling endeavors in space exploration today. Rovers like Curiosity and Perseverance are scouring the Martian surface, analyzing rocks and soil for any telltale signs of ancient life. The discovery of even fossilized microbes on Mars would be a monumental event, confirming that life is not unique to Earth and raising the tantalizing possibility that life is abundant throughout the universe. Section 7, Earth, an oasis in the solar system. As we explore our solar system, we are struck by the uniqueness of Earth. While other planets and moons show signs of past or present geological activity, none possess the same delicate balance of conditions that allow life to flourish. Venus, our closest planetary neighbor, is a scorching inferno shrouded in thick clouds of sulfuric acid. Its runaway greenhouse effect has turned the planet into a hostile pressure cooker. Mars, once potentially habitable, is now a frigid desert, its atmosphere stripped away by the solar wind. The gas giants, Jupiter and Saturn, are colossal worlds composed mostly of hydrogen and helium. While they may harbor vast oceans beneath their swirling clouds, the extreme pressures and temperatures make them unlikely candidates for life as we know it. Earth stands alone in our solar system as a beacon of life, a testament to the rare and precious conditions that make our planet so special. Section 8. The Habitable Zone, a Cosmic Sweet Spot. The habitable zone, also known as the Goldilocks zone, is a region around a star where conditions are just right for liquid water to exist on the surface of a planet. This region is not too hot, not too cold, but just right for life as we know it to thrive. The location and width of the habitable zone depend on the size and temperature of the star. Smaller, cooler stars have closer and narrower habitable zones, while larger, hotter stars have more distant and wider habitable zones. Earth's position within the Sun's habitable zone is one of the key factors that has allowed life to flourish on our planet. But the habitable zone is not static. As stars age, they brighten, causing the habitable zone to shift outward. Section 9. Exoplanets. Expanding the search for life. In recent decades, astronomers have discovered thousands of planets orbiting other stars, known as exoplanets. These discoveries have revolutionized our understanding of planetary systems and have ignited our imaginations about the possibility of life beyond Earth. Among the thousands of exoplanets discovered, a handful stand out as potentially habitable. Kepler 186f, located about 500 light-years from Earth, is the first Earth-sized planet discovered in the habitable zone of another star. Gliese 581d, located about 20 light-years away, is another promising candidate, believed to be a super-Earth with a potentially habitable environment. These discoveries are just the tip of the iceberg. As our technology improves, we are finding more and more exoplanets, including those in the habitable zones of their stars. The search for life beyond Earth is just beginning. Section 10. The Universe, an ocean of possibilities. The universe is vast and ancient. Billions of galaxies, each containing billions of stars, stretch out across unimaginable distances. With such a staggering number of stars, it's statistically improbable that Earth is the only planet in the universe that harbors life. The sheer scale of the universe suggests that life, in some form, may be commonplace. Perhaps there are other planets out there teeming with life, with their own unique ecosystems and evolutionary histories. The possibility of extraterrestrial life is one of the most profound questions facing humanity. The answer, when it comes, will forever change our place in the cosmos. Section 11. The search continues. The search for extraterrestrial life is a daunting but exhilarating endeavor. It's a search for answers to some of the biggest questions we can ask. Are we alone? Where did we come from? What is our place in the universe? Scientists are using a variety of methods to search for signs of life beyond Earth. From listening for radio signals from advanced civilizations to searching for biosignatures in the atmospheres of exoplanets, we are casting a wide net in our quest for cosmic companionship. The discovery of extraterrestrial life, even microbial life, would be a transformative event for humanity. It would force us to reconsider our place in the cosmos and to grapple with the profound implications of not being alone. The search continues, driven by our insatiable curiosity and our desire to understand our place in the universe.